the world's biggest tunnel boring machine to an abrupt halt. It's just 1,000 feet into a tunnel that's planned to be almost 10,000 feet long.
China's mega machines have done something the world never saw coming. Digging through mountains and lifting entire bridges into the sky, these colossal inventions have shattered the limits of modern engineering. Behind every tunnel, bridge, and skyscraper stands a beast of steel and hydraulics pushing the limits of construction. How did China rise from buying foreign machines to building the world's most advanced engineering monsters? And what are the jaw-dropping creations that have stunned even experts? Join us as we discuss China's mega machines that just broke every rule of physics. China's tunnel boring machines. When people talk about China's rising engineering prowess, they often look at its skyline, or the high-speed trains racing from Beijing to Wuhan. But the real story begins deep underground, where massive machines chew through rock, soil, and even the seabed. These are China's tunnel boring machines, or TBMS, the silent giants that have completely revolutionized the Chinese construction sector. Surprisingly, China had to import every single TBM it used just a few decades ago. However, it builds more of them than any other country on Earth today, exporting them to over 30 nations and setting records that have stunned even the engineers who once supplied them. And the wildest part was how the Chinese learnt to build these massive earth crushers. You see, back in the early 2000s, foreign-made TBMS dominated every major project in China. The technology was expensive and closely guarded, so Chinese engineers began learning by assembling and maintaining imported machines. Within 10 years, that changed completely. Companies like China Railway Engineering Equipment Group, known as CREC, and China Railway Construction Heavy Industry, CRCHI, started designing their own models. These new homegrown machines were not just copies. According to construction experts, Chinese TBMs were better suited to China's complex geology, from soft delta mud to hard mountain rock. One of the first big demonstrations of this new strength came during the South to North Water Diversion Project. We are talking about the largest water engineering scheme in human history.
It's known in Chinese as 南水北调, or southern water diverted to the north. It involves two long routes, eastern, middle, and a western one yet to be built.
Engineers had to dig hundreds of kilometers of underground tunnels to channel water from the Yangtze River basin up toward Beijing and the arid northern plains. Ordinary machines would have struggled with the rugged terrain, but Chinese-made TBMS handled it with relentless efficiency. Some of them cut through limestone mountains, while others pushed under rivers, keeping the massive flow of construction moving without interruption. The success continued under the sea. The Jiaozhou Bay Tunnel in Shandong Province, stretching more than 7 kilometers under the seabed, proved that Chinese TBMs could conquer conditions once thought too harsh. The shield machines had to withstand enormous water pressure and corrosive salt environments. Each cutter head measured over 15 meters in diameter, large enough for a bus to drive through, and carved through the seabed layer by layer with surgical precision. In cities like Beijing, Guangzhou, and Shanghai, TBMS became the heartbeat of urban expansion. Beijing's subway network, one of the largest in the world, owes much of its speed to these machines. At their peak, more than 100 TBMS were running simultaneously under the capital, each carving a different section of tunnel, coordinated to millimeter accuracy. Engineers called it the subterranean orchestra, where each machine worked in rhythm to deliver new subway lines that now carry millions daily. China's tunnel boring industry is no longer measured only by how fast or how deep its machines can dig. The focus has shifted to intelligence and adaptability. The latest generation of TBMS is equipped with sensors, data systems, and AI-assisted navigation that allow them to adjust automatically to different soil pressures and rock hardness. A modern TBM made in China can weigh more than 2,000 tons, cost over 20 million yuan to produce, and run non-stop for months underground without human intervention in the cutting chamber. Beyond the constructions, China also holds several world records in the field. Their largest shield machine, named Jingxiu, measures over 17 meters in diameter, one of the biggest ever built in the history of the world. In Shenzhen, another massive TBM recently completed a tunnel that passed less than 10 meters below skyscraper foundations, all without disturbing the surface. And as the tunnels reached their final segments, the next challenge was already waiting on the surface, in the form of machines that would build not under the ground, but over it. Machines like the Iron Monster. Keep watching because there's no machine more incredible than this. SLJ 900/32 Iron Monster. The first time the Iron Monster rolls onto a construction site, it looks less like a machine and more like a moving bridge. At 91 meters long and 7 meters wide, the SLJ 900/32 bridge erecting machine stretches farther than a football field. It weighs around 580 tons, yet it glides on 64 wheels that move with surprising grace. There are no cranes in sight, no swarm of workers pulling cables. The Iron Monster simply drives onto a set of concrete pillars, lifts a massive bridge beam weighing up to 900 tons, and slides it perfectly into place, all by itself. Built by Beijing Wow Joint Machinery Company, this self-propelled bridge builder changed how China constructs its elevated highways and high-speed rail lines. Before it came along, bridge assembly required cranes that were difficult to move and dangerous to operate in mountainous regions. Every new segment had to be lifted, aligned, and welded with complex scaffolding systems that took days to set up. The Iron Monster erased all of that. The iron beam can lift, position, and crawl forward span by span, repeating the process with machine-like precision. The SLJ 900/32 earned its nickname for good reason. Its long steel frame bends and adjusts as if alive, powered by hydraulic arms that can pivot, tilt, and extend. Its front section holds the new bridge beam, while the rear rests on already built spans. As it moves forward, it creates its own track, setting each beam in place before rolling onto it to reach the next position. It can complete a span in about 3 hours, where traditional methods might take days. The entire operation happens with minimal human assistance, and because it needs no cranes, it can work even in areas with narrow roads or steep valleys. Between 2008 and 2020, China built more than 35,000 kilometers of high-speed railway, more than the rest of the world combined. Much of that network stands on elevated bridges built by machines like the SLJ 900/32. The engineering behind it is just as impressive as the sight of it. The SLJ 900/32 runs on multiple power units, each capable of independent steering, allowing it to make sharp turns despite its size. Its balance system keeps every movement steady, even when lifting beams that weigh almost twice as much as itself. Sensors monitor tilt and load in real time to prevent accidents, a level of control that makes the process as safe as it is efficient. It can move forward, backward, and sideways, adapting to any project layout. This behemoth was never imported nor licensed. It was designed and built entirely within China. After its success, several international companies ordered similar machines for their infrastructure projects, with China exporting versions of the SLJ 900/32 to countries like Malaysia, Indonesia, and Turkey. As it rolls across valleys and rivers, it leaves behind not only bridges but also proof of what industrial imagination can achieve. And just beyond the edge of those bridges, other giants wait to rise. Machines that lift, pull, and build even higher than the Iron Monster ever could. Kunlun Girder Erecting Machine. The Iron Monster had proven its worth on flat terrain, but many of China's new railways and highways needed to cross steep mountains, deep valleys, and winding gorges. Traditional bridge machines could not adapt to such rough geography. The answer came in the form of a new generation of technology, the Kunlun Girder Erecting Machine. Built by China Railway Construction Heavy Industry, the Kunlun series takes the idea of self-propelled bridge builders to an entirely new level. It was designed for the heavy lifting required on high altitude and curved bridge projects, the kind that test the limits of balance, power, and accuracy. Each of its spans can carry beams weighing over 1,000 tons and measure more than 40 meters in length. The name Kunlun was chosen after the legendary mountain range of western China, and that name fits perfectly. This machine was born to work where the land itself is a challenge. Unlike earlier models, the Kunlun girder erecting machine does more than just lift and move beams. It can adapt to slopes, adjust to different pier heights, and even rotate beams in mid-air to align with curves. Hydraulic legs extend and retract independently, helping the machine maintain stability even when one end rests on a completed span and the other on raw terrain. The entire system is controlled through synchronized computer commands that calculate the load balance and movement speed in real time. Are you wondering how much this machine has actually delivered to the Chinese? It will surprise you. In Sichuan and Yunnan, the Chinese built elevated railways across mountains so rugged that conventional construction would have been impossible. These machines worked hundreds of meters above valleys, placing beams with less than 5 millimeters of error. They cut construction time by almost half compared to older methods, and did so while keeping workers safely away from dangerous heights. Each Kunlun can finish a span in under 3 hours, combining speed with accuracy that manual systems could never achieve. The scale of engineering behind Kunlun is astonishing. A single unit can measure over 100 meters in length and carry multiple power systems to drive its independent modules. It runs on high-pressure hydraulics capable of exerting lifting forces of several thousand tons. Sensors along its frame constantly feed data to onboard computers that detect stress or vibration before they become problems. It's not just a machine. It's an intelligent construction system that works like a coordinated team on its own. The Kunlun series stands as proof that no mountain is too high for modern Chinese engineering. And just beyond the ridgelines where Kunlun works, other mechanical giants prepare to rise, machines designed not to place beams, but to lift entire worlds of weight in a single motion. XCMG XGC 88,000 crawler crane. When you see the XCMG XGC 88000 crawler crane, you'll probably take it for a small building. Standing over 100 meters into the air, its steel lattice boom stretches so far that it disappears into the clouds. Built by Suzhou Construction Machinery Group, this machine is the heaviest lifter on land, capable of raising loads of 4,000 tons, about the weight of 400 double-decker buses or 2 Eiffel Towers. It is not just a crane, it is a statement of how far Chinese engineering has come in mastering extreme precision and raw power. The story of this giant began in 2010, when XCMG decided to build a crane that could take on the most demanding industrial projects in the world. China's rapid industrial expansion meant new oil refineries, nuclear power stations, and offshore platforms were rising faster than ever before, and each required lifts that older cranes simply could not handle. The XGC 88,000 was the answer, a fully self-propelled crawler crane that redefined heavy lifting. One of the first major performances of the crawler crane was at the petrochemical plant in Shandong province, where it lifted a massive reactor tower weighing more than 2,000 tons and placed it perfectly into position. That lift set a world record and shot China into the global heavy industrial machinery hall of fame. Beyond raw power, the XGC 88,000 also represents a shift in China's industrial mindset, from building fast to building precisely. The crane combines advanced hydraulic control, digital monitoring, and safety systems that constantly adjust load distribution. Operators rely on live data readouts that show real-time stress and wind resistance, allowing them to react instantly to changes. The machine can rotate its massive boom with the grace of a dancer, even while holding thousands of tons mid-air. While the Iron Monster and Kunlun machines conquered the challenges of bridges, the XGC 88,000 takes those same values of innovation and precision into vertical space. And high above the ground, where cranes like this finish their work, another kind of machine is waiting. One that pumps life into skyscrapers from the inside out. This is beyond incredible. The Pump King machine. Rome was never built in a day, and the towers spread across Chinese cities didn't just rise overnight. There is one machine that quietly makes that possible, the Pump King. It is not as tall as the skyscrapers it helps build, but without it, none of those towers could stand. The Pump King is China's most powerful concrete pumping machine, able to push thick concrete more than 400 meters upward, high enough to reach over 100 stories. Every drop of that mix moves with exact control, as if guided by a steady hand instead of pressurized steel. The Pump King was developed by Sany Heavy Industry, one of China's biggest construction equipment manufacturers. Before it appeared, most concrete pumps could not push beyond 200 meters without losing pressure or consistency. As buildings grew taller, that became a serious problem. Sany's engineers decided to solve it the only way they knew how, by breaking limits. They built a machine with a pumping pressure that exceeds 40 megapascals and a hydraulic system so strong it can move 70 cubic meters of concrete every hour. That means a tower floor can be poured in a fraction of the usual time, and the mix reaches the top as smooth and even as it left the ground. The Pump King shot to fame during the construction of the mini Sky City in Changsha, a 57-story skyscraper that went up in just 19 working days. That speed shocked the world, but the real story was in the machines that powered it. The Pump King worked alongside modular steel assembly systems, feeding concrete non-stop into the structure as the tower grew floor by floor. Its pumping boom extended like a mechanical arm, reaching where cranes could not. By the time the top floor was set, it had pumped thousands of cubic meters of concrete without a single clog or delay. But that wasn't all. The King's boom sections move with millimeter precision, guided by electronic sensors that track every sway caused by wind or vibration. Its twin-piston system maintains a constant flow, preventing the jerks or pauses that can ruin the density of concrete at high altitudes. It also recycles pressure energy, making it both powerful and efficient. Every tower it helps build becomes another mark on the skyline, from Beijing's business districts to the new cities rising in inland provinces. And as those towers climb higher, China's builders look for new ways to connect them across rivers and valleys, where another type of machine takes over, the one that lays the tracks that tie the whole country together. CYP 500 track laying machine. Meet the CYP 500 track layer, one of those marvels that turn impossible engineering dreams into everyday reality. Stretching hundreds of meters long, this steel giant is the heartbeat of China's high-speed railway expansion.
In a feat that seems straight out of a high-speed thriller, China has unleashed its renowned high-speed rail track laying marvel. With just 7 operators, this powerhouse can lay over 2 kilometers of high-speed rail track in less than a day.
It moves like a slow creature across unfinished rail lines, laying heavy steel rails and concrete sleepers with pinpoint accuracy, down to a few millimeters. Each movement is a perfect dance between strength and precision, something that once took hundreds of men and days of labor but now happens in minutes. Built by the China Railway Construction Corporation, the 500 CYP represents years of refinement in automated railway technology. It can carry, position, and lay rails weighing more than 60 tons each, while also handling the placement of pre-stressed concrete sleepers that anchor the track. The machine does all this while crawling forward at a steady pace, guided by GPS and laser measurement systems that ensure every section lines up perfectly. In the world of railway construction, even a deviation of 2 millimeters can lead to vibrations that compromise speed and safety. The CYP 500 eliminates that risk. If you find that interesting, what you're about to see will completely shock you. China's rail revolution depends on machines like this. Since the early 2000s, the country has built over 40,000 kilometers of high-speed rail lines, the largest network in the world. Without advanced automation, this pace would have been impossible. The CYP 500 can lay more than 1.5 kilometers of track per day, meaning that a single team can finish a 200-kilometer section in just a few months. That efficiency is one reason China's high-speed trains now link cities like Beijing, Shanghai, Guangzhou, and Chengdu at speeds reaching 350 kilometers per hour. Each CYP 500 costs tens of millions of yuan to manufacture, but it saves far more by reducing construction time and errors. More importantly, it brings the dream of seamless connectivity closer. Every time its steel frame moves forward, it marks another meter of progress in a system that has changed how China travels, trades, and grows. The sound of its hydraulic arms locking another pair of rails into place is the rhythm of development itself. Steady, exact, and unstoppable. When its work is done and trains begin to race over the tracks it laid, the CYP 500 retreats silently to the next frontier, leaving behind ribbons of steel that stretch over plains and through mountains. And just beyond those lines of progress, another kind of giant waits, one that can reach even deeper underground and push the limits of tunnel construction where no machine has gone before. Banat construction robot. That wall-climbing robot looks like something out of a science fiction movie, right? With a spider shape, it grips the side of skyscrapers, inching its way up with mechanical legs. But this is not fiction. Designed by Chinese engineers, Banat represents a new chapter in how construction work is done safely, quickly, and with precision. Instead of scaffolds and swinging harnesses, this robot crawls across glass, concrete, and steel surfaces using vacuum adhesion and magnetic grips that keep it stable even at dizzying heights. Weighing less than 100 kilograms, Banat can carry heavy tools and perform complex tasks like painting, welding, cleaning, and surface inspection. Its onboard sensors scan every inch of a wall, mapping out where to move next and detecting cracks or corrosion invisible to the human eye. This makes it more than a worker. It is also an inspector and a data collector. Its cameras feed live images to engineers on the ground, who can make instant decisions without risking anyone's life on scaffolding hundreds of meters above the ground. The robot's precision comes from its multi-jointed legs, each powered by electric actuators that mimic natural climbing motions. It can run through rough surfaces, corner edges, or curved glass walls without slipping. Some versions even switch between magnetic and suction modes depending on the building material. Developed for China's booming urban skyline where construction never slows down, Banat can work day or night and never tires. This kind of automation demonstrates a major shift in Chinese construction, one that values speed and safety together. As Banat scales higher and faster, it also suggests that in the near future, machines take on the dangerous jobs while humans plan, monitor, and innovate from below. And somewhere ahead, those machines are not just climbing, they're beginning to build on their own. Yihong Ginyun 2. The Yihong Ginyun 2 is one of those rare creations that make the ocean itself seem small. It is not just a ship, it is a floating construction yard, a sea giant designed to carry, launch, and assemble some of the heaviest structures humans have ever built on water. At nearly 200 meters long and over 40 meters wide, this massive semi-submersible vessel can lift and transport more than 20,000 tons of cargo at once. It can haul floating bridges, oil platforms, massive cranes, or even sections of offshore wind turbines, then set them precisely into place on the open sea. Built by China's Yihong Heavy Industry, the vessel uses a ballast control system that allows it to sink its deck below the waterline to load massive equipment, then rise again once secured. This submerging and resurfacing process lets it take on floating cargo that no conventional ship could handle. Once loaded, it travels slowly but steadily across open waters, maintaining perfect balance even in rough waves. It can also position itself within centimeters of its target location, which is crucial for marine constructions, where accuracy determines the stability of what is being built. During the construction of the Hong Kong-Zhuhai-Macau Bridge, the world's longest sea crossing, ships like Yihong Ginyun too carried entire bridge sections and installation equipment between construction points. Instead of building everything piece by piece on site, engineers could prefabricate sections on land, load them onto the vessel, and float them directly into position. This approach saved months of labor and reduced the risks associated with open sea work. Thank you for staying with us. Which of these wonder machines impresses you the most? Share your opinions with us in the comments section. If you enjoyed the video, like, share, and subscribe to our channel. Also, click the following video on your screen and you will enjoy it.